Welcome back. Hi, yeah, welcome back. How are you doing today? You doing good? All right. Let's continue on our conversation. The last time that we met, we were talking about inequalities, but only in one triangle. And we used those inequalities to be able to say something about how the sides are related to each other and how the angles are related to each other. Today, we're going to use those same inequalities to help us compare between two different triangles. And the way we're going to do that is with the following two theorems. We're going to use the Hinge Theorem and its converse. Do y'all know what a hinge is?
Like the thing on the door that makes it open and close.
Yeah, that thing, the thing on a door, makes it open and close. And it seems like really, really obvious if one door is open more than the other, that space between the door and the door frame is bigger than the other door that's closed more. Yes? Right? It's like, well, duh.
Yes.
And that's what these theorems are saying, but we're using triangles to simulate the door. So the Hinge theorem states, if two sides of a triangle are congruent to two sides of another, and the included angle of the first, let me zoom in a little bit because I realize that that's really small. And the included angle, there you go. So two sides of one triangle congruent to two sides of another, and the angle between those sides, one is bigger than the other, then the third side of the first triangle is longer than the third side of the second triangle. This is a, well, duh kind of thing, right? And the converse says, if two sides of a triangle are congruent to two sides of the other, and the third side in the first is longer than the third side of the second, then the included angle in the first triangle is greater than the included angle of the second. So the first one talks about that included angle, how wide is it open, and the second one tells us what's the distance that it is open, and that tells us how wide it is open, that angle measure. Okay? Again, doesn't give us precise angle measurements, it just gives us a way to compare to say which one is bigger than the other. Let's go ahead and jump straight into our examples. Let's look at your choice, 1, 2, 3, or 4.
What were the names of the thing?
Hinge and converse of Hinge theorem. Hinge theorem is the first one, and converse of Hinge theorem is the second one. Number 4 is being requested. All right, we're going to look at number 4. Here is number 4. We're going to look first for sides that are congruent. So I have these two sides being congruent to each other. And then I have this side for this triangle being congruent to this side for this triangle. And so really what we're after is the comparison between this angle and this angle. So let's look at the sides opposite those angles. So if I look at this side has a measure of 28. And then I'm going to look at this side, and this side has a measure of 42. Which one is bigger? The 42, which means this angle is bigger. And so we're going to write that the measure of angle WYZ is greater than the measure of angle XYW. Now when I'm writing them out by hand so that you can tell the difference between an angle measure and the inequality, I'm going to write the inequality bigger than the angle symbol. I'm also going to try very hard to make the bottom part of the inequality flat. I did not do so well on this red one, I'm sorry. But if you look at the text written portion, you can see that that bottom one is flat. Okay, so that bottom one being flat means angle, otherwise it means inequality. It's hard for me to do it later, guys. It's hard for me to do it when I'm writing, and so I'll just make the inequality bigger. All right, feel good? Yes? Easy peasy. All right, we have 3 more examples on this page. Do you guys want to see any more?
3.
Number 3, because it looks different and hard to tell, right? We don't have any congruent symbols? Yeah. All right, no congruent symbols, so I need to go off of measurements. Do I have 2 sides with the same measure? Yes. I have the 24s, and I also have the 30s. So really, I am comparing this side, which has a measure of 50, to this side that has the measure of 48. Which one is bigger? The 50, which means which angle is bigger? Yeah, XZY or just Z is going to be larger than this angle C, ACB. So then we're going to write that the measure of angle Z is larger than the measure of angle C. Now it's okay if you write out the full name of the angle, all 3 letters, that's fine. You're just being very, very specific. I only needed to use the 1 letter for the vertex here because I didn't have any other angles sitting at that vertex. All right, feeling comfortable with these?
Yes, we can put it down.
Beautiful. This one?
Yes.
Okay. Another look at the other example. Yeah?
Wait, can you go back to the other one?
This one?
Yeah. I think that one.
Okay. All right, you're going to switch the page in. Okay.
Okay.
All right. Here we go. We've got examples 5 through 10, and there's a few that have one that has a variable. So I want to focus on that one first, number 8. So let's look at number 8. We're going to look for sides that have the same measure. I see these 2 sides have the same measure. They're both 10. I see this side is shared between the 2 triangles, so it's going to have the same measure. Which means really what I'm doing is I'm comparing this angle to this angle and trying to decide which one is smaller. But they didn't give me a value for x, did they?
No.
I don't know what x is. But it doesn't matter what the value of x is.
Wait, miss. Oh, never mind.
It doesn't matter what the value of x is. Here's why. I know that x, whatever its value is, isn't going to change in the middle of my problem. So as long as I keep the same value for x throughout the entire question, each time I'm looking at it, I haven't broken math. Okay, so later please. Thank you. So what I'm going to do is I'm going to pretend there's a value for x. Okay? So what if x was, I don't know, give me a number. 12. Okay, what if x was 12? So if x was 12, then I'd have 12 minus 3, and that would be 9. And I'm going to compare that to 12 plus 3, which is 15. So if x is 12, the red angle is bigger. Okay, well, let's change the value of x. What if x is 6? Okay, so we're going to run the same idea. 6 minus 3 is 3. 6 plus 3 is 9, and the red angle is still larger. Yeah, it doesn't matter what the value of x is. Because it's the same and I'm adding to one of them and I'm subtracting from the other, the one I'm adding to is always going to be larger than the one I'm subtracting from. So ST has a greater measure than does RS. I'd like to look at 11 and 12 next. We're going to do some solving for x. Which one would you like to see, 11 or 12?
Both.
Both? Okay, let's do 11 first. The directions say write an inequality for the range of the value of x, which means your answer is going to be something like x is smaller than some number, x is bigger than some number, or x is between two other numbers. Okay, so it's going to be one of those three things. Let's look at what we have. I have two triangles. I'm told that these side measures are the same. This side is being shared between both triangles, so those are going to be the same measure. And I'm told that this angle is larger than this angle, which means this side is bigger than this side. And so that's our inequality statement. 40 needs to be larger than 4x minus 10. Bless you. We're going to solve this for x, and when it's done, it'll tell me what values x has to be bigger or smaller than in order for this setup to work. All right, going to add 10 to both sides. So I have 50 is greater than 4x. Let's divide both sides by 4. And I'm going to get x is less than 12.5? Okay. Nice. All right. And there's my inequality. As long as x is less than 12.5, we should be good. Now, if I knew what size that pink side was that was shared between them, then I could use the inequality theorem from last time to help me narrow this range down again. Okay, great. It's less than 12.5, but could it be -4? Well, obviously it couldn't be negative, but how small could we make this thing? Could we make it 1? Could we make it half? Could we make it 3? I don't have any way to say that right now. So all I know is right now, as long as x is less than 12.5, we're happy, and this works. Okay. We're going to switch over and look at number 12 here in a second. Start looking at it. Try to find the sides that are congruent, because that's the first setup you need. Angel, you're being requested at the door. Thank you. All right, can I switch? All right. Here's number 12. I've already color-coded it, as you've seen in the other examples. The blue ones are congruent, the pinks are congruent, and the reds and the green are different. Which side has the bigger measure? The 36 is larger, which means the angle directly across from it is going to be larger than the angle directly across from the 30. So my inequality statement is 33 is greater than 3x minus 3. And now I can solve this for x. Shout it out as soon as you get a response. 12? Okay. I agree with you. X needs to be less than 12. That's it. This is another one of these moments where it's going to be super, super easy to overthink it. Okay? Don't overthink this one. Okay, we're going to look at the proofs on the back side of the page. There's a typo to fix on the second proof. All right, we're going to fix the typo in the second proof first. Please come in and on reason number 3, please change it to given and then add that statement to the given. Okay, so those are the changes that we're making to this one, because there's reasons. There's reasons that I'm still trying to figure out. We're going to make this change right now.
The print does not like you.
Right? The printing doesn't like me. Start filling it out if you see it. All right, I'm going to go ahead and look at the first proof, and then we'll come back and we'll grab this one. Okay? So if you didn't get a chance to finish writing it, that's okay. All right, here is the first proof, zooming it out so that we can see the whole thing. All right, what we were given was that Rx is equal to Sx. So these two pieces are congruent to each other. The next thing we're told is that the measure of angle SXT, that's this angle right in here, its measure is 97 degrees. 97 degrees. All right, so there is the measure of that angle, which means that angle is related to this side somehow. We have to prove that this side ST is greater than this side RT. Which means we need to be able to say something about this angle right here and how it compares to the other. All right, let's look into our proof and see what we have. The first statement does not start off with the given. That's okay. It doesn't always have to start with the given. I've given you the rule of thumb of start it with the given because if you don't know where to start, that's a great place to start. They started by talking about the definition of a linear pair. If I look at this blue line, I've created these two angles here on the right and here on the left. They form a straight line. They are a linear pair. And because they are a linear pair by definition, they are also supplementary. And so the question to you is, what does supplementary mean? They add to 180. So by definition of supplementary, I'm going to write the measure of this angle plus the measure of this other angle equals 180. I'm not actually going to write the measurements. I'm just going to write the measure of. Whoops, I forgot a symbol, didn't I? There. Why did I just what? Because when you're doing a proof, you have to show all the little steps. You can't just, poof, I'm going to subtract. Because the reasons are going to be like, well, why'd you subtract? And you'd have to go, well, because they add up to 180. And when you put it in this equation, and then so you have to write every little step. All right. The next thing is that the measure of angle SXT equals 97. Where did they get that? From the given. Very nicely done. Thank you. So we're going to add given as the reason. And then we're just going to read through here. Looks like the next thing they do, I'm going to start putting lines to make it easier for me to keep track of. Looks like they substituted. They replaced measure of SXT with 97. And then there's the subtraction that he wanted to do. And then we compared. We found our inequality. 97 is bigger than 83. Substitute from the numbers back to the names of each thing. So that way, then we could state that things were bigger than the other thing. And then we're going to write down our last given. Reflexive property. Tx congruent to Tx or equal to Tx. There it is right there. So now we have two sides and the included angles, one being bigger than the other. That means that the sides, one is bigger than the other, and that's our Hinge theorem. Yeah? Fairly okay? Okay. Let's look at the second theorem. Scroll down. All right, this is the one where we made changes to our given statements and to one of our reasons. So please make sure that you've updated your given and reason for number 3. I'm going to zoom out here so that we can see the figure and we can start coloring in. All right, I've been given a rectangle, and I have this rectangle A to F to B to C back to A. Now, this proof is requiring some information about rectangle that I haven't given you yet. Spoiler alert, we're going to study these in depth after Christmas. So here's your spoilers.
21 days?
Yeah, no, way after, like next year. Next calendar year, not next school year. All right, so here's the spoilers on triangles that you'll need for this. The corners are right angles. And the opposite sides are congruent.
What does that say, Miss?
Corners. My horrible handwriting struck again, I'm sorry. The corners are right angles and the opposite sides are congruent. Now let's look at the rest of the given. We have ED is congruent to DC, so I'm going to come into my picture. Here's ED, here's DC, they're congruent. I'm going to go ahead and use these properties to start marking my rectangle.
Wait, Miss, you still have the first name?
Right corners are right angles, opposite sides congruent. And I'm doing those markings now, so I'm marking all of the corners as right angles. And we're going to mark the opposite sides congruent. So this side is congruent to this side, and this side is congruent to this side. But I don't know if they're congruent to each other. It looks like a square, meaning all sides are congruent.
Can AE be congruent to AC?
Can AE be congruent to AC? No, we can't say that right now. If we prove it, then sure, we can totally say that. AD is congruent to DC.
No, but like EA is not congruent to AC?
No. At least we don't have any way to say that yet. I mean, we could get there, and if we could get there, then sure, I'd put the markings. This is all I can say for right now. All right, let's take a look and see what we've got. Okay. I have the given, and then I have AD congruent to AD. How did we get that? Yeah, reflexive, it's congruent to itself. So we have the reflexive property. All right, and then we have our new given, because I can't figure out how we use that reason to make that statement. I tried it, so we're just going to make it a given to make it easier for the moment. I'll keep chewing on it. All right, and then we're going to use the Hinge theorem. Okay, Hinge theorem says I've got this angle ADA, this one here, and I'm going to compare it to this angle right here. And it says that this one is bigger than this one. And so by the Hinge theorem, that side is bigger than the other side. So we're going to write that. Side AEA is larger than side AC. That's why we couldn't say they were equal.
Oh. I always knew that, Miss. I just want to make sure you're good.
Good. I'm glad. Thank you for helping me out. Opposite sides of the rectangle are congruent. So I could write these pair of sides or these pair of sides. Which one is the most helpful to write?
Probably the AC.
Probably the one containing the AC, because I want to get to use that. I want to use the FB also. So we're going to write AC is equal to FB. Opposite sides of the rectangle are congruent. And then by substitution, we're going to replace, here's AE, here's the red. We're going to replace the AC in this statement with the FB from statement number 5. Yes? All right. That's all I had for you guys today. Thank you very much.